Okay, so let me just share a secret with you. I missed rehearsal this morning, so this is my rehearsal, and let's make sure I can operate the computer. The title, I'll try not to read my slides, but the point of this title is that I want to be clear that what we have is an enterprise deployment of MySQL. It's not a web app or a web deployment. It's made much more challenging because the deployment is run at the scale of an internet application. And that's made even more challenging by the fact that it supports a rapidly growing application and workload. So I've briefly worked at Informix on database internals, and then I spent a decade at Oracle. Eventually left for a startup, and I briefly worked on embedding Berkeley DB into an appliance, but I didn't stick around long enough to watch customers try to use it. And then I ended up at Google in the fall of 2005. After a few months, I started the MySQL engineering team within Google. We have two goals as part of that team. The first is that we have to improve MySQL to meet the needs of the application. And many times when you're using MySQL, you have two choices. Can I do it the easy way to adapt to MySQL, or can I make MySQL adapt to me? And for a variety of reasons, we frequently end up making MySQL adapt to the application because depending on how many users you have, making a few people suffer to enhance the database is easier than making all of the applications adapt. The other thing we do is we support a large production environment. So on a daily basis, I SSH into machines. If someone doesn't understand or like the way a server is behaving, we have to explain it and attempt to fix it. Depending on the severity of the problem, we try to fix things faster than not, but usually there's some amount of time where we have to tolerate and adapt to behavior. I've been fortunate enough to be allowed to blog about my experience working on this. And so at mysqlha.blogspot.com, I occasionally stand on my soapbox or just share some of the details about the work that we do. And then I publish the Google patch for MySQL at code.google.com. And that patch has almost all of the changes we've made to MySQL, and it certainly has all of the changes that might be useful to others. I've been very happy that parts of the patch have leaked out into other releases that are much easier to consume. So the Google patch is for MySQL 5.0.37. Not the easiest thing to use. It's a gigantic patch with a lot of changes. InnoDB with the 1.03 plugin and Percona, I can't see if they're here. I hope someone from Percona is here, have incorporated some of the technology or just attempted to solve some of the same problems we are solving in the patch. The other thing that I do is I agitate for MySQL. So things that might be infrequent problems for some, because I get to use more servers, turn out to be intermittent problems for me, and so I try to push for solutions ahead of time. So what is MySQL at Google? You might notice that I will give a lot of details about my experience, but some numbers I might not say. So at times I'm vague, and that's how it is. But you'll have to trust me. It's a large, important enterprise deployment. Trust me. Even though you might think I just spend all my day writing the blog and responding to other people's blogs. The QPS rate in aggregate on this deployment is tremendous. The number of machines we use is reasonably large. It runs on many commodity machines, and so commodity definition, well, the definition is the same, but you're actually getting big hardware now, multi-core servers, multi-disk servers in the commodity range. We depend on replication, NODB, and stability. And so our experience with the stability has, I think, been remarkable. We are now at a point where the mean time between a crash from software problems is measured in the centuries for a given server. And we've been able to make minor fixes to the software that we use to get to that point. And so I think that having a server that has an average uptime, in theory, of a few hundred years, if you were able to power the machine for that long, it's a nice thing to be able to count on. We're a typical sharded deployment of MySQL. We have many primary database servers and many replicas per primary. And the database service must always be available. So I want to make the point that we're not using, well, the reason we're using MySQL is because we did, and because we've been able to depend on it. So we are passionate about transactions. We use this for an important application. Customer experience is impacted if the database service is not good. And so we've been successful with it and happy with the results. In general, what makes this successful? I mean, it's change management. The database itself is providing change management, but also the way you go about improving your use of it is judged on how you manage change. When you are developing a server or adding features, the one approach is accumulate a set of features, push them into the binary, deploy the binary, and see what happens. And guaranteed you have a debugging nightmare at that point in time. You have no idea which of your assertions are invalid and which of your fixes or improvements don't improve things. Deployment is the same thing. Deployment is a very dynamic environment. You have things changing all the time. Your network services that you depend on, the routers, the DNS, network hardware, applications that share the network, the server you use, the version of the operating system, the compiler, the shared libraries. Everything's changing all the time, and when something breaks, you need to be able to correlate that with what has changed. So the typical example of sharding, for those who don't deal with this all the time, we physically split the data set across multiple servers. Depending on the complexity of your schema, you'll have one or more tables that can serve as a root, and all of the data that joins to that table is then distributed based on that root table across multiple servers. A unique aspect of MySQL is the number of replicas you can connect to a master and still not make the master database crash. I don't know. I tend not to see people reporting numbers about this, but I think you would be amazed at the number of slaves that you can connect to a master. And we kind of, I guess, did this from trial and error. We just keep on adding slaves, and eventually, if the server is still stable, well, then you know it works. When I started working on MySQL, the deployment that we had, the viability of it, there was a lot of doubt about it. We had some serious problems, and slowly, over the last 3 years, we've fixed many of those problems. And my team would love to take all of the credit, especially if the bosses are watching, to take all of the credit for this, but we can't. The people who debug, enhance, support, put up with customer support, occasionally angry customers like me, document and test and build MySQL. You stood once. Can we stand some people again? MySQL people? Can we have some people stand? MySQL. Is Monty here? Someone. I want to thank you. I appreciate, at times I may complain about things, but I appreciate what you've done. The next person, and is Heikki here? Is Heikki Turi here? Ken wasn't sure if he was here. So Heikki, if you can hear me, thank you. InnoDB is the most beautiful database software I've ever worked on. And I've worked for a few database companies. Not only does it work well, but as a programmer, it's a joy to work with. And when we change it and improve it, it's remarkable that the changes are usually very small and are able to keep the server looking good. Yasufumi Kinoshita started was a spark for a lot of the work that we did, who's now contributing to Percona. And Percona itself continues to be a big source of ideas for the problems that I need to solve in my build. And then finally, I have a remarkable team of highly productive people that I work with. I don't actually get to program all the time anymore. I do a lot of testing and getting features done by others into production. So the history of our deployment has 3 stages. There's prehistory. So I know that we used MyISAM, and I think we used another relational database server. Not much is known about that time. I haven't met any of the people who were working back then. Someone wrote a blog about it. You can search for it. I can't vouch for the accuracy, but it describes some of the details. Eventually, recorded history begins. We began using MySQL 4 with InnoDB. Things got a lot better at that point in time. A few enhancements were made to MySQL. And then modern times. I arrive, and I document what I do, so we have some record of it. And I say, wow, this is a database system. I know this, because I was working on a project with some other people. They didn't really need my help. This was an opportunity for me to contribute. And so we've really begun to enhance MySQL, and we upgraded to 5.0. So what is an enterprise database? I've said that our deployment is an enterprise database. One of the key factors is that consistency matters most. That when choosing between consistency and availability, that you would choose to be consistent, meaning you never want to be in the state where you have multiple servers claiming to be the master database, both accepting transactions that you'll have to resolve after the fact. It's complex. You have many database accounts. You have many database tables. The schema itself is probably difficult or impossible to draw on a small piece of paper. And generally, the full schema is understood by a few people, but everyone has their part of it. Audit is a concern. You need to know who is doing what to the database right now, who can do what to the database, and who did something to the database last week. You might have to track down a row change. Who was responsible for changing this row? Legacy is an issue. So a successful application eventually becomes a legacy application. The original authors are gone. The shortcuts that were taken to get the product to market eventually become concerns, but you tolerate them. Control is an issue that once you have audit, you need to be able to show that you can enforce access to the database and detect or log what was done. And finally, transactions. We're passionate about we don't want to lose any data. If we put something in the database, it needs to be there. If it's put in the master, it has to match what's on the slave. So data quality is a serious concern for us. as we've been working on the database, the problems that we've solved have changed over time. I think they were all interesting at the time we solved them, but they've become more complex. So initially, the initial problem was, how do we build this? So the person who was building the binaries before me transferred, and I just was pointed to a directory. Here's how you build the RPM. Have fun. Eventually, this became something that required a dedicated build machine because it was statically linked on a desktop machine, which at one point in time was similar to the production environment, but eventually diverged. So we had a binary with static libraries from my desktop machine that production machines did not really like. So we moved to hermetic builds, and hermetic builds were great. We have libraries and the binaries we use and the header files we use off of the desktop. But this creates a whole new set of problems that eventually you learn to love automake and autoconf, because you have to debug these interesting build scripts that require a lot of expertise to keep things healthy. So we built it. Now what? Well, we have to test what we have and prove that it works running in production. Start with regression tests. So MySQL has a suite of regression tests, but they're generally easy to pass. So the next thing that we went on is, well, we have queries running in production. Can I use that in any way? And so using Python, built a tool to sample queries from production and replay them against multiple test servers running old and new versions of the binary. And then with that, we would test for query result correctness and query performance side by side and look for, not at an individual query level, but at a workload in aggregate. If I sample 10,000 queries from production, is it faster or slower? Does the server crash? And we've been able to identify a few problems, but more than anything, this just gives us faith that the new binary is likely to work. Concurrent with that, we built a lot of stress tests, generally focused on the replication changes we made. And so we have, at this point, we've made our slaves crash safe. So you can kill a slave at any point in time. It comes back. It won't duplicate transactions. It won't miss transactions. It will come back and be able to replay the rest of the replication workload. And so with that, we just run tests overnight where we're continually killing the slave, letting it come back up. For a while there, we were finding bugs. At this point, it's stable. And so we have much more faith that the replication changes we've made are safe with respect to crash safety. Eventually, we realized, hey, MySQL has this Valgrind option for the test suite. Let's try it out. So everything gets run through Valgrind. That usually takes a day, a little bit of time to look through the warnings to see if there's anything new. Drizzle people might laugh at this next point, especially Stuart. If Stuart's here, we discovered the value of compiler warnings. So build the server with -wall, look at the complaints, and see what you need to fix from that. And that has actually found more than a few bugs in the code that we've added to MySQL. And then the final thing we do is check for data drift. If you let a slave run the replication workload with the new binary, compare the contents of the tables to a slave with the old binary, and see if they have the same data. So we tested it, we built it, we've tested it, now we have to deploy it. The simple approach is just put it out there and hope for the best. And if you're not looking for problems, you might not find them. And we did that once without much luck. We ended up having a file descriptor limit on the binary was much lower than we expected, and we had some bugs in production because of that. So the first thing we do when we put it out there is we need to look or need to search the error logs that are written by the database. Well, when you have a large number of servers, you can't manually step through these files. So we have some very messy Python that is used to aggregate the contents of database error logs and look for known problems and unexpected problems and report back. And then combined with that, we have a cron job that on a daily basis goes out and looks at every database server and looks for crashes and then reports back. So we can see as we're pushing out a new binary, is my crash rate changing on a daily basis? And usually there's that moment of panic when we get that first new crash on a new binary, and then usually it's not a cause for panic, but I always get upset the first time I see the new crash. Deployment also requires us to have some amount of automation to find servers that we think are unhealthy and remove them from service. There's servers that are obviously unhealthy when they just crash and don't come back up, but there's a few ways that servers can crash every minute or every hour, and we need to spot those as well. So then monitoring this. The enterprise monitor people were here, and I liked what I saw, except I have a feature request, which is show user statistics. So I monitor top-down. I look for which account or which table is using more load than it was yesterday or last week, and then I can begin to look at things at a query level. So we have monitoring tools, usually not as nice looking as the professionally done ones, but so we kind of solve. It's amazing with awk and bash, you can actually do a lot of clever monitoring. But I'd prefer to have the easier way. I can find queries in my case, but it usually takes 30 minutes, not 5 minutes. So I like the speed up. But we generally try to look at things top down. We started out by sampling show process list, and we still do that. And that catches some queries, but it doesn't catch the fast queries. And it seems to undersample the fast queries. So show user statistics gives us a view of how many resources are being consumed by which account, and then show table statistics gives us the idea of how many resources are being consumed per table. From that, we generate daily and weekly workload reports, including QPS. When we first deployed this, the QPS on critical servers was growing 2x per year, and people would constantly say, "Oh, panic! 2x per year. We can't double our servers 2x per year. It's just unacceptable." It turned out, after deploying the better monitoring tools, that we really did not. It was kind of a bogus workload. It was queries that did not need to be run on that server, and within a few months, QPS growth stopped on those critical servers. So having the ability to have good monitoring tools can really do a lot more performance enhancement than just about anything else. And as always, you learn what to watch after you weren't watching it and it caused a production problem. So the next thing is, once we began to watch the server, we had a better idea of what could be done to improve this. So I had some ideas initially about how to improve MySQL, and they were silly ideas. But after about 6 or 9 months, we began to figure out what we needed to do. It helps if you deploy what you build. If you're just building and you're remote from production, you are not going to understand the trade-offs that you need to make when you're adding the features. And it helps to monitor. The more you look at, the more problems you will spot. So a brief pitch on some of the features that we've added. At a high level, we want replication to be self-healing. We want to be able to set up a number of servers, and just, if a server crashes, if it's a master, another slave takes its place. We don't have that functionality. But we are, making the slaves, making this easier to manage. So the first 3 projects we did, we had Wei Li was working in the team, someone I worked with at Oracle, and who's now at Google with me. And he was on the project for about 1 year. And then in the last month of the project, he came up with the idea and implemented mirror bin log. And we had it running in production pretty fast. And this feature, which we actually stopped using, maintains a copy of the master's bin log on slaves using the replication protocol, so that if the master fails, we have the bin log that it was writing on another server. We made slaves somewhat crash safe. This is Domas's favorite feature, and I think he was sad when we told him we're pulling it out. We store the slave replication state in the InnoDB transaction log, so on crash recovery, we can synchronize the two. Semi-sync replication, I'll explain in another slide, but it gives us slightly better guarantees on that we're not going to lose a transaction if the master dies. We've added checksums to bin log events. This is in the v3 Google patch, so that we can confirm the contents of the bin log events on the slave. Shane Bester is not here, but I want to call him out. Many of us had some problems in 5.0 running replication on a flaky network connection. And there was a corruption error that would go undetected until you tried to rerun an event from the relay log, and it was very hard to debug. I made no progress on it. Eventually, Shane figured out some crazy way to simulate a flaky network, found the bug, and within a few weeks, I had a fix, and I was very happy about that. So thank you, Shane. Global transaction IDs is something that MySQL, I think, is working on. We did our own version of it. It makes it possible to automate failover of a slave, or of many slaves, when you have many slaves connected to a master. Right now, it's a manual operation. With this feature, we can automate that. We're in the process of making slaves fully crash safe, which is replacing the somewhat crash safe functionality we added. And we found and fixed many bugs as a result of crash testing. With the ability to do crash testing, you can put much more stress on the server. So semi-sync replication, I think, is overstated what it promises. It does promise something. The thing it promises is you will lose at most 1 transaction per connection if the master dies. So each connection can have at most 1 in-doubt transaction. The second thing it gives you is if you have an active or a misbehaving client, it can help rate limit the commit rate that they will do to your server. So it can balance access to the server for other clients. What it does is commit occurs on the master. After commit, after InnoDB has accepted the transaction, you send out a request to the slave to ACK. Eventually, one of them acknowledges the ACK request, and you return to the user. So the failure scenario is if you commit, another transaction can view the outcome of that commit, and then you can crash without that transaction reaching a master. So it is not synchronous replication, it's not cluster, but it is a useful feature. Global transaction IDs. The key problem is replication state is the file name and position for a file that's only on the current master. That data is not valid on the new master. So with global transaction IDs, what we have is a counter that's monotonically increasing and preserved across master failover. And then that counter can be used to map from the old master to the new master. Performance features. This is my favorite thing. I run a lot of performance tests. We've made MySQL run much faster on multi-core and multi-disk servers. We're not the only ones doing this. So 5.4, Michael? Does it have the 1.03 plugin? 5.4?
The features I talked about would be in 5.4.
Okay, so it has the important features too, beyond the SMP performance. So that's a big deal. Unless you want to apply patches on your own. Percona is also doing this. Percona is making MySQL and InnoDB a lot faster. So it's nice that we have and Drizzle is doing it with a different approach. They're not doing the storage engines yet. They're doing above the storage engine. And then finally, PBXT. To my dismay, I thought I had the fastest storage engine until I tested the recent PBXT releases. And for CPU-bound workloads, it was faster than anything I can do. So I was somewhat disappointed, but happy. We've made the parser faster for 5.0. A big difference from the 5.0 release to the 5.1 release is that the Sun performance engineering team was participating in the 5.1 release. And so performance problems that lingered in 5.0 were spotted early and resolved. So the type of problems we encountered with 5.0 probably don't reproduce in 5.1. We spent a lot of work to integrate with TC-Malloc, and part of this is just running it in production and learning to trust it. It is open source software published by Google that does very fast, scalable memory allocation. And for some workloads, it makes a very big difference. And one of our recent projects is we are backporting the connection pool code from MySQL 6 to 5.0. And we're also pushing our feedback on what we think the performance problems are, so we can get people to focus on fixing those sooner. We've added a lot of manageability features. Our focus isn't on the UI as much as it is on command line tools. We've integrated MySQL with the monitoring. The big thing was show user statistics and show table statistics. Again, what enterprise monitoring is doing will, I believe the customer quotes that they had, that you will get these, you will spot these problems. JDBC was configured wrong, and it's doing set auto commit, or it's doing 5 silly commands every time it connects. There's a lot of problems that you don't know you have that the monitoring will show. Another thing we've added that we haven't spoken about too much is roles. So we want users to authenticate separately, but we don't want to re-specify privileges when they have the same privileges again and again. So we came up with a convenient way to do roles in MySQL. And that gives us much better scaling on the overhead for managing permissions. Wait, there's more. So I'm not going to get through all my slides, which is fine. We have a project for row change logging. There's a talk by Gene Pang on row change logging. This is kind of like row-based replication, but it's in 5.0, and it's easier to consume for external tools. So we want to sync the database with something else. Online data drift checking is kind of a re-implementation of MK table checksum from MatKit. Only it has more support for running in production so that we don't knock over a server when we're doing this. Flopulator is just another messy set of bash and awk scripts that I use for running cron jobs to analyze server health on a longer level. So the big thing I look for is crashes to confirm that new binaries are okay. Query tester I described runs queries in parallel, compares the results. So it makes sure that the new binary is getting the same results as the old binary, and it also looks for performance problems. We actually had, in 5.0, it's really found one, well, it's found more than one, but a big performance problem was equality propagation in 5.0, and some of our custom code we added didn't agree. And so we found a few queries that were way slower with 5.0 that we were able to fix. Row change logging, master slave, something else. Something else is Bigtable or GFS. If you're at Google, it's Hadoop or Oracle or a big data warehouse, potentially, if you're someone else. And it allows you to do real-time replication. The key is you can do batch extraction, and you don't need this tool. But then you have stale data. And stale data isn't as valuable as current data. So you want to do the replication between the products in real time. Things that you can then do is fast parallel query on your internet scalable data store. You can do change notification. You have a full audit log of every row that's changed. If you're a real database geek, you can do materialized view maintenance using that data. And I think someone actually published, I don't know if he's here. Someone was publishing a technique on how to do that with MySQL. Maybe this would make it easier to do. Online data drift. You have master and slave. How do you compare them? If you stop replication, you go out of business. You need to keep the servers running. We did what MK-table checksum does, is through MySQL replication, we compute partial table checksums and then diff them. So no statements run for too long. Servers are not tied up for too much time. A difference with the tool itself is running this in production. After launching this, we realized that, we have some slaves that are busy, and maybe we don't want all slaves to participate at all times in the checksum computation. And so we had to figure out how to disable it for some slaves. There's more to life than software development. Google has two types of engineers, software development and site reliability. Site reliability, their mantra is the site must not go down, and in our case, it's the database must not go down. MySQL within Google is not this typical data service that is provided, because we don't use cluster, so we have a dependency on a single node. So that actually makes the problem much harder. We can't have that single node fail. And the general philosophy at work is design your service so that there's redundancy and automatic failover. I wouldn't be up here. My life would be a lot easier if we were running cluster. So, production crises. We've had lots of crises. We've had 2 bouts of out-of-memory errors. The ironic thing is the fix for the first bout was in 4. We forgot to port the fix to 5. I forgot to port the fix to 5. And Chip Turner, I just want to say his name, fixed it in 4, and then he reminded me that when it came back in 5. It's somewhat painful. We've had unstable kernels. We've had servers running for a while without core files, which is okay because MySQL gets the stack trace in the error log, except when you use 64-bit binaries. So at that point, we had no core files and no stack traces. So it's somewhat intuitive debugging when you get crashes. It was something we fixed, but it was not fun for a while. We've had underpowered slaves. You don't want slaves to be a lot slower than the master because they can't keep up. We've had database load growth, query storms. How do you defend a server against a query storm? You have clients connecting from everywhere. If you can't disable the account, it gets tricky. Corrupt relay log events found the reproduction case again. Chain saved us a lot of pain by rapidly getting that fix. So I am not going to sit with all these slides. I will go to my open problems. Online schema change. Lots of database servers do this in a very complex fashion. It would probably take a long time for MySQL to do this across all storage engines. But the MySQL way is different. Do it on the slave, fail over to the slave. No downtime. Is there a framework for automating this when you have a lot of slaves? I don't see it yet. Automating failover is not there yet. And as more and more people have enterprise deployments, you want that. Frameworks for those who we all rewrite the same code to do the same things for managing our servers. And if we had a larger, we could benefit from a common framework for doing some of those tasks. Synchronous replication. We don't have it. Cluster has it. It would be great if we had an option to have it. Perhaps there is a future. MySQL replication team has spoken about this. Minimize replication delay. We are all attempting to economize now, to put more load on a server, but you do not want to create replication delay when you do that to a slave. And finally, solid-state disk, multi-core servers. Sun has many core servers, and Intel will soon have many core servers. How do things scale? It's a new problem. Finally, my soapbox. Run a server in production. Eat your own dog food. Very important. Work at a large systems company. You learn how code ages. You learn how to debug messy code. And I'm out. So thank you for listening to me. I'll be around to talk to people. I'd love to hear stories about how other people have solved problems similar to mine. Thank you.